Hello dear students, your Saurin sir is back once again, but this time with an interesting topic named as bimolecular nucleophilic substitution. We generally in short name it as SN2 reaction. SN2 is nothing in simple, you can say nucleophilic substitution of the second order. Now why it is a second order? That's a question in our mind first of all. According to the topic chemical kinetics, the mechanism of kinetics you can understand. According to that topic, when both the reactants which are participating in the reaction, here you can see I have already placed the hydroxide ion which is your nucleophile over here and chloromethane as a substrate. Both are basically reactants. When concentration of both the reactants according to chemical kinetics is taken into consideration, the order of reaction is considered to be of second order. So we have shortened it as SN2, that is nucleophilic substitution of the second order, or you can say it's a bimolecular nucleophilic substitution. Okay. In this reaction you can see we have taken chloromethane. You know chloromethane, where carbon is a tetrahedral, having a tetrahedral geometry, it's chloromethane. So here the carbon atom is, I would say, sp3 hybridized. And it is allowed to react with a hydroxide ion. You know hydroxide, OH minus. It's a minus sign, so basically I would say it is a nucleophile. It is having tendency to donate electron or electron pair. So in short we can consider with respect to our lower standards as Lewis base. So I have taken a strong Lewis base and tried to react with already existing compound chloromethane. Now what happens? As OH minus is a strong nucleophile, it will have a tendency to attack the carbon which is bonded to Cl. Why? Because Cl is more electronegative than the existing carbon atom, and so Cl will have a tendency to slightly pull away the electron of carbon towards it. As a result, this carbon atom will be partially positively charged and chlorine atom will be partially negatively charged. Taking the advantage of the partial charges and carbon having partial plus charge, this OH minus attacks the carbon from the rarer side. Mind you, it will attack always from the side other to which the Cl minus or the existing group is. You can see over here Cl minus is existing, so OH minus attacks the carbon. This is carbon, dot is carbon from the rarer side, or you can see the opposite side. Interesting part is that during this reaction, heterolytic fission doesn't occur. Directly the attack of a nucleophile on the carbon directly takes place. So that becomes an interesting part. Not only that, the initial stage as the reaction proceeds, the very first you can say the stage when comes, it's always a slow process, and as you know according to the chemical kinetics, slow process is always a rate determining step. So here what happens, this OH minus attacks the carbon from the opposite side, and as a result this transition state is created. Transition state is created where interestingly this carbon atom is converting into sp2 hybridized carbon. Initially it was sp2 hybridized. Initially it was sp3 hybridized. Now it is sp2 hybridized. So what happens? Now both OH and Cl both are negatively charged. But now OH minus is more electronegative than Cl minus, and finally Cl minus leaves the carbon atom. So what happens? At the end of the reaction the process becomes fast and automatically you have CH3OH instead of CH3Cl. So you have it was a chloromethane, now you have methanol, and Cl minus is set apart, set free from the compound. So here you can see the rate of reaction. I'll write it for you. The rate of reaction is, depending on the concentration of, this is your hydroxide ion, it is your nucleophile, and this is your chloromethane, it's a substrate. So the rate of reaction depends on the you can say both the reactants, where the reactant one reactant is a nucleophile and the other is substrate. So what happens? The nucleophile attacks the substrate simultaneously, and as a result a transition, this is a transition state which is observed, or which you can find over here. This is your transition state. So actually talking, this reaction is only a single step reaction. Mind you, SN2 reaction is only a single step reaction. But why it is SN2? Because it depends on the concentration of two things, that is both the reactants. The nucleophile is one of the reactants and the substrate is another reactant. So this is an interesting mechanism you can understand, and it is a nucleophilic reaction because you know it is the nucleophile which is participating in the reaction. So in general we always write chloromethane reacts with alcoholic, or you can say aqueous KOH, let us say simply aqueous KOH, and that gives methanol plus KCl. Why this reaction happens is because of this, that KOH reacts with what you can say chloromethane or methyl chloride in aqueous state, fine, and that gives you methanol with KCl as a, it's the same reaction, but this is the mechanism which depends on two reactants with respect to their concentration. So this is an interesting reaction named in short as SN2 reaction. In the next episode we'll come down with one more, and that is SN1 reaction. But before that, prepare this thoroughly, because both the reactions, when you are not thorough with, they'll get mixed up and you will always have the confusions. This particular SN2 reaction was given by the great scientist Hughes and Ingold, and so I say that this reaction should be prepared thoroughly. Wish you all the very best. Prepare it thoroughly. We'll see you for next reaction, that is SN1 mechanism. Till then, goodbye.